Hello. So this is a continuation of our understanding statistics to understanding data science. So in this video, this is continuation of a previous discussion, that is regression analysis, understanding regression analysis. So in this session video, we will discuss about more understanding of simple linear regression basically. So once again I'm repeating, this is who knows statistics well and who knows the concept and formulas, then there is no need to spend time on this. You can jump into other topics. In this video we will try to understand the concept of regression, simple linear regression basically. My name is Savyasachi. This is a continuation of part of statistics, understanding statistics in data science. Okay, let's start. So we will deal with the same example what we discussed in previous session. That is, we have 6 members of income on monthly basis, as well as we have those people investment on monthly basis. Okay, right? So here we understood in our previous sessions what is meant by independent and dependent variable. In our example, income is independent variable, whereas investment is dependent variable, right? So we done all the scatter plots, configuration, and algebra line equations, and we seen those things. Now we will try to understand simple linear regression. So simple linear regression will comes into picture when you are dealing with one independent variable. Just understood. When you are dealing with one independent variable, that independent variable is determining when one independent variable is exposing dependent variable, then we will go for simple linear regression. And when we have multiple independent variables, then we will utilize other regression models like multi regression model and non-linear regression models, as well as logical regression models. Those are different kinds of regression models are there. So now in this video we will try to concentrate on simple linear regression. Simple linear regression when we will use when we have one independent variable, and based on that given random independent variable we are going to predict the dependent variable. That is what we are going to understand. So we now what is when we will use simple linear regression. In our case, let's imagine we have our income, we are dealing with income and as well as investment, right? So let's imagine one situation where you forgot somehow your income data of those 6 people, but you have the data of only investment of those 6 people data. For example, investment of these 6 people data, we have 5 rupees, one person invested, second person 10 rupees, third person 2 rupees, and 3 rupees, one person 1 rupee. This is, just imagine we have some set of data, a random sample, 5 rupees, 10 rupees, 2 rupees, 3 rupees, 1 rupees they are investing. But in this case we don't have these people's income data, we have only their investment, 5 people investment data. So in this case, if someone comes and asks, if some person earning some x amount, that is our independent variable, can you predict the dependent variable, that is investment? because we don't have income data here, it is very tough to find an equation, basically. In this type of scenarios, what we will do is, normally we will calculate the mean x bar, mean of this investment. So in this case, this dependent variable, so we will call it as y bar. Okay, our mean will be, in this case, 4, right? In this case we will get 4 as the value. Then what we will do is, we will draw a graph, plot this graph, this x and this will be y. This 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for example, 3, 4 is like this. So if you observe, this is a straight line equation. When it will comes, in previous videos we discussed about y predicted value equals to beta 0 plus beta 1x. When beta 1 is 0, then we will see this kind of graph, basically. So in our case, 4 is our mean, right? This is our y bar, that is 4. In this case, 4. So what we will say, what this graph and what we are going to tell is, irrespective of income, we are always predicting, irrespective of your income, we are always predicting you are going to invest 4 rupees. You are going to invest 4 rupees in all the scenarios. In this case, this is our predicted value, right? 4 we are predicting all the time, but these are real scenario, really they are investing. So what is the difference between 4 and 5? We will compare each and one element in this group. So 5 and 4 plus 1, somewhere here it will be plus 1. This is 10, second element is 10, then this will be plus 5, right? Third element is 2, that means it will minus 2. This is 4, 2, right? Minus 2. And third one is 3, that is minus 1. Fourth, last element is 1, that means we will see some plot minus 3. Okay, minus 3. If you see, these are the data points we plotted on our graph based on our mean, dependent variable mean. So we will call these data points as residuals data points. We will call these data points as residual data points. That means these residual data points will show us what is the error in our equations, or how far we are from actual values. We are saying 4 is our predicted value, but we are far away from, for first variable we are far from plus 1, for second plus 5, and third one is minus 2, fourth one is minus 1, fifth one is minus 3. So we are far away from that much distance, basically. So if you consider in this scenario, all plus r, these r we are representing as residuals. In this case, plus r minus r always will be 0. If you calculate the sum of these plus and minus, it will be always will be 0. So this is what we are explaining here. When we don't have independent variable, but we have only dependent variable, and we are going to predict some value, how we are going to predict? By using mean of that dependent variable. We always say your mean will be your predicted value, and by using this we can know what are the differences between actual and our predicted value. Those points we will call them as residuals. So normally what we will do is, square of sum of error, SSE, SST, SME, we will calculate those. What we will do is, we will square plus 1 multiplied by plus 1, plus 5 multiplied by plus 5, plus minus 2 multiplied by minus 2, minus 1 multiplied by minus 1, minus 3 multiplied by minus 3, and we will sum all the data and we will call that as SSE. Basically that value we will call it as SSE. If our SSE, square sum of error, is very huge, then our whatever we are going to predict, that value is not accurate, not that much accurate basically. Once again, let me tell you, statistics used to find statistics always used to find the truth, but it is very tough to decide whether it is very tough to test the truth. Once again, I already discussed this point. So in this case also, it is very tough to predict the value very accurately, but we will try to find that value as much as possible. Okay, so in our previous session also we explained this. 4 is our mean value. That means we are besides that 4 value, we are going to predict some value basically. So some upper limit and lower limit also we will calculate using this linear regression, simple linear regression. So now we understood when we have one dependent variable and how to calculate the residuals, as well as what is meant by error, square of sum of error, right? Now let's imagine we have data of both investment as well as income of 6 people. Let me note down income as well as investment of 6 people. Now we have both data, income as well as investment. First person income is 50 rupees, second person income is 100 rupees, third person income is 90 rupees, fourth person is 80, fifth person is 40, sixth person is 70, and first person investing 5 rupees, second person investing 10 rupees, third person 25, fourth person 8, 6, 11. These are the values we have. Let's imagine so this is our income data and this is our investment data. So first we need to calculate, this is our independent variable, right? This is our dependent variable. So when we got this data, first we need to calculate the mean and standard deviation of this data. So this I already calculated. I have 71.666 as some values as mean. This is x bar, and in this case y bar is 10.833. so this is our x bar, mean of this income. This is y bar, mean of investment. So first we need to calculate the mean of these both data. Then we got mean of independent variable as well as mean of our dependent variable. Then if once you know the mean of these dependent and independent variable, then we can say we can draw one graph. This is our 71. Okay, 71. Let's imagine this is 71.66 value, here 10.88 for example. So these 2 points colliding here, this is our data point, right? This is the value of our independent variable 71.x bar. This is y bar 10.88. so this point, the mean of both independent and dependent variable, when you plot in a graph, we will call that point as centroid. So why we need to know this centroid point in our graph? Basically, when in our simple linear regression or other linear regressions, we always try to find the equation model of our based on given sample data. We will try to find one equation. On that equation we will apply the random in independent variable and we will get the predicted value. So we will try to find one equation based on given data. after finding that equation, when you are interpreting the independent variables and when you plotting that graph, always your linear regression model equation should go through this centroid, otherwise your linear regression equation is not proper. Okay, understood? That's the reason we should know the what is the centroid of our data point, what it is. So always our linear regression equation, our line should go through this centroid, then only we will call that equation is good, otherwise something going wrong and we need to recalculate our equation. Okay, so now we understood what is meant by residuals, now we understood what is our centroid, right? Now so as we know, the equation of linear regression model is, we already discussed this one, y, this is the value we are going to predict, y cap I equals to b0 plus beta 1 b1 x. This xi is the random x, y cap equals to b0 plus beta 1 xi. Xi is our random independent variable. When you are providing this value, we are going to predict this value, right? So this is the line equation. Basically this is line equation. So now we know in our previous session also we discussed about this line equation, y predicted value equals to b0 plus beta 1 x. So to know the b1 value, we have one equation. Let me write down this: sigma x xi. Xi is our each independent variable, xi minus x bar. X bar is our mean data, sigma of xi minus x bar multiplied by yi. Y is our dependent variable minus our dependent variable mean divided by sigma xi minus x bar whole square. So this is our this is the formula to calculate the b1 value. How we will know? By using this formula, sigma xi is every element minus the mean of the independent variable multiplied by yi represents each element of our dependent variable minus y bar is our dependent variable mean divided by same value, xi minus x1 whole square. So this is the formula where by using we will know the b1 value. Once we know the b1 value, we can know very easily the value of b0. Y bar is our mean of dependent variable minus b1 x bar. So this is our equation, y predicted value equals to b0 plus b1 xi, where xi is a random given independent variable. So to calculate b1 value, we need to perform this equation: sigma xi minus x bar multiplied by y minus y bar divided by sigma xi minus x bar whole square. Once we know the b1 that value, then we can calculate b0. b0 equals to y bar is dependent variable mean minus b1 value we will know, b1 multiplied by x bar. So these are the formulas to calculate the y bar. So now we will try to calculate these values so that we can come up with some equation. That equation, once you know, we can predict the value of our dependent variable investment by uh, placing that random given input independent variable into our formula line equation. So now we know the equations. Now what we don't know is b0 value, sorry, b1 value we should know. B1 value, to know that value we should calculate the formulas, right? Formulas. First value we will try to xi minus x bar. Okay, xi minus x bar, y I minus y bar, yi minus y bar. Next one is xi minus x bar whole square. So first and fourth value is xi minus x bar multiplied by yi minus y bar. Okay. So let me write down the values of our income and investment. So our values are 50, 100, 90, 80, 40, 70. So each person investing 5 rupees, 10 rupees, 25 rupees, 8 rupees, 6 rupees, 11 rupees. So our x bar value is 71.66. Our y bar value is 10.866833. So these values I calculated in Excel. You can do it your mean calculation from anywhere. Excuse me. So now this is our x, right? This is our y. Now xi minus x bar, 50 minus 71.6. So we will get minus 21.66. So next 100 minus 71.66. So we will get 28 point something 33. So we will do minus each and every element. We will get the values. I already calculated this. So I am just noting down. So these values we got. Now what this is xi means 50 minus x bar is 71. So 50 minus 71 we will get minus 21 something. 100 minus 71 we got 28 point something. Third one is 90 minus 71 we got 18 point something. So 80 minus 71 we got 8.33. 40 minus 71 minus 31. 70 minus 71 minus 1.66. So this is the value we calculated. These values, why we are calculating? To calculate the b1 value as well as b0 value. So same way we will calculate yi minus y bar. In this case we will minus with use this row, this column 5 minus 10.833. So I already calculated 5.833 minus 0.833, 14.16 minus 2.833 minus 4.833, 0.1666 something. So these values are what I am doing each element of in our income 5 minus 10.83. I got minus 583. 10 minus 10, so I got 0.8. 25 minus 28, 14. 8 minus 10, minus 2. 6 minus 10, minus 4. 11 minus 10, minus 0.16. So once you know this value, we can, this value is, this is square, minus 21.66 multiplied by minus 21.6. We will get the value here. So 469,444. This value is multiplication of this 2 times. So next value is 28.333 multiplied by 28.333. So we will get 802.77. In same way I calculated all these values. 336 69. 8.33 multiplied by 8.33, we will get 69 point something. 1002.77, 2.77. So this is the value of multiplication of 2 times. So we got now this. So this is what? This is multiplication of this value and this value, right? Xi bar, xi minus x bar multiplied by y minus. So we will multiply these two values, and we will write down here. So 126.388 minus 23.611, 259.722 minus 23.611, 153.055 minus 0.277. So once we know these values, what we can do is we can sum these two values. Okay, we can sum up these two values. The sum of this xi bar, the total sum of this value is 2683 dot sum 333, and same way this sum is 491.666 values. So why we calculated all the values. Now we know the equation of beta 1. How to calculate beta 1? Beta 1 is, the equation of beta 1 is sigma xi bar, sigma xi minus x bar, yi minus y bar divided by xi minus x bar whole square. So xi minus x bar multiplied by yi minus y bar, this is the sum. Sigma means sum, right? This value 491.60 divided by xi minus x square. This value we got 2683, right? 2683. So we will get the value B1 as 0.18329814. So this is our B1 value. So now we know the B1 value. Once we know the B1 value, we know how to calculate B0, right? B0. Excuse me. All right, already we know that. So let me write down that B0 value formula. B0 is y bar minus b1 xi, b1 x bar basically. So we know what is y bar. So the dependent mean, what is the dependent? Our mean value is 10.833. 10.833 minus, we know the B1 value already we calculated, that is 0.183229, 0.183229 something. So multiplied by the mean of independent variable. The mean of our independent variable is 71.666, 71.6667 something. So once you calculate this, we will get the value as minus 2.2981, minus 2.2891 value. So this is our B0 value, and we know the B1 value 0.183229, right? So our line equation to predict the value of yi equals to B0 plus B1 xi, right? This is our line equation. So we will replace this B0 value with this 2.891, B1 value with 0.18, xi will be the random value, right? random variable basically. So let me replace this. So our line equation y predicted value equals to b0 plus b1 xi. So our b0 value we already calculated, minus 2.2981 plus b1 value we already done that previously, 0.1832 multiplied by xi. Xi will be the random independent variable. So what this is our simple linear equation for our given sample data. So if you see, we first, this is our line equation, and we calculated b0 first, then we calculated beta 1, and we replaced those values and we got this equation. So what exactly this equation is telling us means, for every rupee, the investment amount, the investment amount x, for every rupee the investment amount x increase, we would expect the investment. So for every rupee investment, for every rupee the bill amount, this value. So for every rupee investment, we are expect this much increase in our investment basically. So for every rupee the investment increase, for every rupee the income increase, we would expect this much amount increase. So this is our xi will be the income basically. So for every rupee income increases, this much amount will increase on our investment. So that is what this line equation saying about basically. So now we calculated the line equation of this. So we know all our incomes of our data basically, right? We are given data. So our income data is 50, 100 and 90, 80, 40, 70. This is our starting problem. This is our income data. So what we are need to do is, instead of this xi, if you replace this xi with 50, 100, 90, 80, 40, 70, we will get the predicted value of every income. So this multiplied by xi will be this investment. Let me write down the income values also here, so that these are actual income values, and this equation will give the predicted value of investment. So actual investment is 5 rupees, 10 rupees, 25 rupees, 8 rupees, 6 rupees, 11 rupees. So this is our income, this is our investment, actual investment. So this is our, we found some equation, that equation will give the predicted value, predicted investment given based for each and every income. So when we replace 50 with here and 100 with here, 90, 80, 40, 70, we will get the values, right? So I already calculated those values. So when you replace 50 here, we will get the value as 6.866 something, and when you replace 100 value here xi, we will get 16.02 something, and when you replace 90 in xi, we will get 14.19, 14.19. When you replace 80 here, we will get 12.36. 12.36. When you replace 40 here in xi, we will get 5.031. When you replace 70 here, we will get 10.52. So these set of data are our predicting values. So once you know the equation and income, when you are replacing your income here, so we are predicting these values. So